So our Bernoulli distribution is a special type of discrete probability distribution, in as much that we only do the one trial. And from this one trial, there are two possible outcomes. We can either win or we can lose. And instead of using the words win and lose, we use the words success and failure. So what we do is we let the random variable x denote the number of successes in our one trial. So if we were to lose, so if we failed, then x would be 0. We've got no successes. If we were to succeed, or we were to win, then x would be 1 because we've had one success. Now we can't get any more than one success because we're only doing the one trial. So it's impossible to have x to be anything other than 0 or 1. So x is 0 if we were to have failure, and x is 1 if we were to have a success. Let's have a look at a few practice problems to kind of get the hang of what's going on here. So here we've got a pre-written example. So we flip a coin once and we say that we succeed if we get ahead. Let the random variable x denote the number of successes achieved in our one trial. So let's say we wanted to build a probability distribution table. So we have our x and our probability that x is x. Now, it can either be 0 successes or we could have 1 success. So the probability that we have our one success, the probability that we succeed, is the same as the probability of getting ahead. So that is 0.5. And therefore the probability that we fail would be 1 minus 0.5, or in this case, the probability that we get a tail, however you want to think of it, would also be 0.5. Now this may also be written another way. It might be written like this. The probability of x is equal to 0.5 if x is 1. And it's also equal to 0.5 if x is 0. So in this particular Bernoulli trial, we've got equal probability of success as we do failure. So it's equally likely to get ahead as it is to get a tail. Now, just like our discrete random variables, we can calculate the expected value, the variance, and the standard deviation of our random variable x. So for a Bernoulli distribution, if I wanted to calculate the expected value of x, this is just equal to mu, which is equal to, for a Bernoulli distribution, just p, where p denotes the probability of a success. And I probably should have mentioned this before, that if I was going to shorthand notation this kind of problem, so we would say that x is a Bernoulli distribution with a probability of success of 0.5. So we're saying it is a Bernoulli. So our random variable x is modeled by a Bernoulli, and in here we put the probability of success. So generally writing x is a Bernoulli distribution with probability of success just being our little p. So in this particular case, p is just 0.5. That's the probability that we get ahead. Likewise, we can calculate the variance of x. And the variance of x is just equal to sigma squared. And the formula for this is just p times 1 take p. So the probability of success, which is little p, is just 0.5. And 1 minus p, well, the probability of a failure is also 0.5. So our answer here would be 0.25. Now sometimes 1 take p is actually written as the letter q. So here we might get p times q, where p is talking about a success probability and q is talking about the failure probability, because 1 take p is just the probability of a failure. If you think about the probability of A versus the probability of the complement of A, the complement of A is just 1 minus the probability of A. So that's kind of what's happening there. We can also calculate the standard deviation. So the standard deviation of our random variable x, well, that's just sigma, which is the square root of whatever the variance is, which we calculated to be 0.25. And the square root of 0.25 is just 0.5. So these formulas should all be somewhat readily available to you when you're solving these problems. And yeah, so we've managed to calculate the expected value, the variance, and the standard deviation. Let's take a look at another example. So over here, example 2. So we roll a fair 6-sided die once, and we say that we succeed if we roll the number 1. So let the random variable x, again, denote the number of successes achieved in our one trial. So x can either be 0 or it can be 1. We can't have any more successes than either 0 successes or 1 success. And the probability that x is 0 versus x is 1. So the probability that x is 1, the probability that we succeed, that happens if we roll the number 1, which is 1 in 6. Which means the probability that we fail is 5 out of 6. So in this particular case, x is a Bernoulli distribution with a probability of success of 1 over 6. Now again, if I wanted to calculate the expected value of x, that is just p, which is 1 out of 6. If I wanted to calculate the variance of x, that is just p times 1 minus p, which is 1/6 times 5/6. And if you put that into a calculator, well, you get 5 out of 36. We can do that much. But if you wanted that as a decimal even for the variance, you would get 0.1389. And finally, the standard deviation, we'll do that up here. That's just equal to the square root of 5 over 36, which is just square root of 5 on 6. And again, if you wanted a decimal for that, it would be 0.3727 would be the standard deviation in this case. Finally, we've got one more example. So here, I'll just remove this from our screen. The probability that Cristiano Ronaldo scores a penalty is 0.85, and he takes 1 penalty. However, this time we play for the opposition, and we denote a success if he misses. So again, our random variable x denotes the number of successes achieved in our one trial. So for us, x is modelled by a Bernoulli distribution, but the probability of a success for us is 0.15 because we want him to miss. So the we can have our probability distribution table, so we can have our x and our probability that x is equal to x. X can either be 0, we get no successes, which would happen if he scored, or we can get 1, which happens if he misses. So if he misses, that's 0.15. If he scores, the probability being 0.85. Again, we can calculate the expected value of x. It's just p, which is 0.15. The probability that we succeed, so the probability that he misses. So just be very careful with the wording of the question. The variance of x, which is just p times 1 take p, or sometimes just written p times q, if q is 1 take p. Well, that is 0.15 times 0.85. And if you pop that into a calculator, which I'll just do now, we get 0.1275. And finally, if you wanted the standard deviation of x, that is just the square root of the variance, which we can calculate into a calculator. We get 0.3571. So that's it for a Bernoulli distribution and our Bernoulli random variables. What it is that we're doing, just to sum up, we've got one trial. We either succeed or we fail, and they're denoted by either a 0 or a 1, where the 0 and the 1 counts the number of successes that we get in that trial.